Hello all, welcome back. This is our second video of 3 for finding limits analytically. In the first video we talked about direct substitution, and when we got an indeterminate we talked about the concept of factoring. So in this one we're going to talk about piecewise functions, and we're going to do a little bit more examples of indeterminates where we do different things algebraically. So let's go ahead and get started here with this question. Notice that 8 and 9 are incredibly similar. Actually, our f of x function are exactly the same. For question 8, it's a little bit easier because here we're approaching x equals 3, and then over here we're approaching x equals -1, which you will see is where we're restricting our graph in our function. So let's look right here at x equals 3. So I want you guys to understand that this is a piecewise function. If you were to graph it at x is greater than or equal to -1, so if we look at x equal to -1, we would graph the function x squared, and then we would graph the line 2x minus 3 when x is less than -1. I don't need to spend any time graphing this. That's not important. That's not part of the problem. What we just need to know here is, where does x equals 3 fall into this range? Well, x equals 3 is greater than, right, greater than -1, so it's 3 is greater than -1, then I know that I'm looking here. So the limit as x approaches 3 of f of x is simply going to be equal to the limit as x approaches 3 of the function that this value falls into. And again, it could be anything greater than -1, and your function would be x squared, because I would be graphing a piecewise function of x squared. So this answer is going to be 9. Okay, just 9. So I don't care about the second part. But if we look on the next part here, I'm actually split. So one function is defined where x is equal to or greater than -1, it's x squared, and it's also defined at 2x minus 3 when x is less than -1. So for this particular example, we have to incorporate, again, our right-hand limit and our left-hand limit. And in order for this limit to exist, these two values have to be the same. So if I find the limit as x approaches -1, again, from the right, okay, so again, greater than is right, I'm going to plug in x squared, and I'm going to go ahead and plug in -1. Well, -1 squared is 1. So that is our right-hand limit. And so again, if we were graphing this function, we would look at where -1 would be, y would be 1. If I want to look at the limit as x approaches -1 from the left, this would be 2x minus 3. And again, I would plug in -1 here. I get -1 times 2 is -2. -2 minus 3 is -5. So I can now say with full confidence that the limit as x approaches -1 from the right of f of x does not equal the limit as x approaches -1 from the right, does not equal the limit to the left of f of x, because 1 and -3 are not equal to each other. Therefore, I can now say that this overall limit will not exist. Okay? And we've done examples like this before. So if this number was equal to this number, then this answer would be obviously whatever these two numbers are. But again, because they're not equal to each other, then you would say it does not exist. All right? So that's how you do those type of questions. Don't get confused if you're looking at a piecewise function and you see that this number is not this number right here. Then simply find. If I said find the limit as x approaches -7 of our function, then I would use this function, right? I'd plug into 2x minus 3 because, again, x is less than -7. So the only time you have to show the right hand and left hand limit is when this number that you see right here is equal to these numbers that you see right there. Okay? So hopefully that makes sense, and let's move on to another example of an indeterminate. Okay, so we're going to go ahead and talk about 3 other types of indeterminate forms here. The first one is if I plug in 1 into our top, we get 0, right? 1 minus 0 is 0. If I get the square root of 1, which is 1, 1 minus 1 is also 0. So just like in the first video, we have an indeterminate form here. And so we talked about factoring. Well, we're not going to factor this. So in this case, we're going to multiply by the conjugate. All right, so this is going to be the multiplication by the conjugate. And I know that some people know what L'Hopital is. And yes, L'Hopital is absolutely an option for these type of questions. But right now I'm going to show you guys algebraically how to solve these limits without using L'Hopital. So again, just like before, you want to keep the integrity of your problem. So you want to make sure that for every problem that you do, if you still have variables, you have to keep the limit as x approaches 1 each and every time. And so I'm going to go ahead and multiply by the conjugate. and the top and the bottom. And essentially, I'm not changing anything, right? Because this is still just 1, so I'm not changing anything. And I'm going to go ahead and put my little parentheses around this. And so a strategy that I want you guys to understand here is this. If you have something that doesn't have a square root and something that does, just hear me out. Never, ever, ever simplify them. Don't FOIL it out. Just leave them alone. And please also make sure that you put parentheses around this, right? Put parentheses around this. And then FOIL this bottom part. Again, remember, what I talked about in the first video is when we have 0 over 0, we want to be able to rewrite this, manipulate our function so something cancels out. That's really important that I say it cancels out. So when we FOIL this, we get the square root of x times the square root of x, which is x. The o and the I terms actually cancel out, right? Negative square root of x plus square root of x, and I get minus 1. And so now, if you guys see this, we're looking pretty good with this problem because the x minus 1's cancel. And so I've got the limit as x approaches 1 of the square root of x plus 1. I can do direct substitution now. Remember, this is the very first thing that we talked about. Direct substitution, and I'm going to get this answer is equal to 2. Okay? It's equal to 2. So that's how you do multiply by the conjugate. Okay? So that problem is that. And then this second question, number 15, is the limit as x approaches 1 of 1 over x minus 1 over x minus 1. So this one here, you want to get a common denominator. Okay, you want to get a common denominator. Okay. All right, so common denominator. So again, oh, by the way, I should have said we should have substituted in first, right? We get 1 here, so we get 1 minus 1 is 0. We get 1 minus 1 is 0. Again, don't ever say it's equal to 0 over 0, so this is our side note. So for this particular example, I'm going to do the limit, and again, ladies and gentlemen, keep limit notation, keep it until the end. So it's going to be 1 minus x over x all over x minus 1. And I'm just going to say to you guys here, and I'll write it in gray. So how was I able to go from here to here so quickly? So I have a fraction minus a fraction, so it's a plus b, or a over b plus or minus c over d. What happens when these are not the same denominator? Then this is how you do the problem very quickly in your head. You multiply a times d. So I multiplied 1 times 1, which is 1. I keep the sign of my fractions, so this had been negative, so I keep it negative. I multiply b times c, so x times 1 is x, and then I multiply what b and d are. And so this is a really nice little trick to know for us to get this in your head very quickly. And so now, ladies and gentlemen, if you divide by, so this is a fraction, technically another fraction. So another thing that we have to remember, so I'll keep this in gray as well. So a over b divided by c over d is the same thing as a over b times d over c, right? So when you divide by a fraction, you really multiply by its reciprocal. So when I do this problem right here, I'm going to say equals, I'm going to do limit as x approaches 1 of 1 minus x over x times 1 over x minus 1. Okay, so that's our next part of our question. I will tell you that, remember, it's all about simplifying. It's all about simplifying. Well, we can manipulate this first part right here, and instead of writing 1 minus x, remember 1 minus x is the same thing as negative x minus 1, right? If I undistribute a negative 1, so what I'm going to do is I'm going to erase this, and I'm going to write down negative x minus 1 here. Okay, so now I'm able to do what we want to do, and I'm able to cancel stuff out. So I'm able to cancel that out. So then we can continue on and do the limit as x approaches 1 of negative, please don't lose your sign, right? Negative, these are canceled out, so I got 1 on the top, I got 1 on the bottom, and now I do, again, direct substitution. Direct substitution, I plug 1 in here, and I get the answer is negative 1. I get the answer is negative 1. Okay? So hopefully that makes sense to you as well. All right, so those are 2 of the other 3 that we're going to, and there's a lot of algebra manipulations, but for AB, we're only going to talk about 3 of them. All right, so there's your second. So let's go into our last question. Okay, so I went ahead and wrote down the problem. This is not in your packet, but this is another example. I think it's in the homework that you guys are going to do for me. So if you guys see this problem right here, we plug in 0 for h, and we're going to get 5 times 5, which is 25. 25 minus 25 is again, 0. And then the bottom is also 0. So this is the last one that we're going to talk about, and this is an expansion. Okay, which just means basically we're gonna FOIL this, right? So expansion, and then by the thing of FOILing. So we're gonna go ahead and FOIL this. So limit as h approaches 0, and then I'm gonna be left with 25 I'm going to do multiply and then I'm going to double. So 10h plus h squared minus 25 all over h. And just like I said in previous examples, guys, the first thing we want to do is we want to simplify. So we go ahead and get rid of the 25s. And if I plug in h here, I'm going to get 0 plus 0 over 0. So that's still going to be that I need to do an extra step or two. So I'm going to look at this problem and say, okay, well, the bottom's going to say h. Well, I can pull out an h here, right? I'm left with 10 plus h. And now I can cancel out yet again. And I'm left with my problem. The limit as h approaches 0 of 10 plus h. And then if I do direct substitution in here, I get the function is actually 10. I chose this problem. Why was this part of your packet? Because we're going to talk about the derivative, the definition of the derivative pretty soon. And using the definition of the derivative, this question is so much easier than doing all this limit stuff. And so we'll talk about that a little bit later on. But the definition of the derivative, for anyone who knows the calculus part, if you were to solve it using that formula, then that would be much easier. So actually, so if you don't want to know about it, you can end it here. That's how we're going to finish the video up. For any of you guys that want to know the shorter way or the definition of the derivative, I would gladly show you now. Derivative, then you're going to say that the function is actually going to be x squared, right? So the function that we're looking at here is x squared. I'm using the definition of the derivative. Your derivative of x squared is just going to be 2x. And then we're going to evaluate that at the number right here, which is 5. So that's the ease. Look how much easier it is just to do it that way right there. So that's the definition of the derivative way, which will be explained to you way, way better in a lot more details in the videos to come. All right, because you're probably thinking, how did you know the function was x squared? And then you can take the derivative and all that stuff. So I'll explain it to you guys later. So that's it. Video number 2 is done, and we are going to then come back and finish up our last little bit in the next video. See ya.